Hey guys, welcome to the backside of homework number 7. So just a reminder that this is kind of a different style of homework than we've been doing for multiple reasons. First of all, we are going to, we actually haven't covered this yet. This is kind of what we're going to be talking about next class. So instead of like homework that we're doing after what we do, this is homework that we are using as a way to start our lesson tomorrow. This is all things you guys have seen in Algebra 2, so it shouldn't be too much. It should be pretty much a review. But just so you know, if you're watching this, you're like, wow, I haven't seen rational functions yet. It's because we did the writing activity, which I think was really important. So that's why we're talking about rational functions now, and that's also what we'll be covering next class. So we're starting out with our parent function, which is going to be the ever basic 1 over x, just like that. So how does that look on a graph? So type of graph, it says it right there. This is a reciprocal, the graph of a, oh man, I can't spell, reciprocal. And it's good. So basically how you graph, I'm going to do it in my calculator first. Hopefully you guys can see this. Oh, perfect. Wow, normally I have to futz with the machine a lot, but not today. So I'm going to go to the graph. Here, as you can see, I was just working on how to solve this because I forgot. I'm not going to lie. Rational functions are not my favorite, but we will learn them together and it will be great. Okay, so clearing out that, I'm going to graph my parent function right there, 1 over x. Hit enter. Hopefully something will happen. And my graph shows up right there. Let me move this to the side. So what do we notice? So first of all, we notice that there's stuff going on in the first quadrant and the third quadrant. So remember, it goes 1, 2, 3, 4. So first and third quadrant. And it looks, we see it continues going on, right? So we're getting really, really close to 0 if we're talking about our x-axis up here, but it never actually touches it. So here we have what's called a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So we have two asymptotes. How I graph this, I'm going to draw the picture here. What I was taught to do, I'm throwing this back to my high school math teacher, who I told you was pretty cool. But anyway, so she would have us check off the asymptote, so we know that it's going to be an asymptote at x equals 0, or if we forgot what an asymptote was, we can just look at this graph and see that it's never crossing that x-axis, and it's also never crossing that y-axis, so we mark it off like that, just so we remember. And then you draw your graph going through like this. You guys know I can't draw, so know that you can probably draw it better than this, but once again in the first and third quadrant, with arrows extending along that x-axis and along that y-axis on both sides. Good, so now let's answer some of these questions now that we have the graph down. So our domain is going to be all real numbers. I'm going to use that symbol because that's what they put on the external assessment. A lot of you guys ask questions about that later. Remember when it would say like, find this composite function, blah, 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 for x is a part of all real numbers. That's what that symbol means. But it's not quite all real numbers, right? So it's all real numbers for domain and for range, except what? Except 0 in both cases here, because it's never going to cross my y-axis, which is the line x equals 0, and it's never going to cross my x-axis, which is the line y equals 0. So it's never, our domain's never going to equal 0, and our range is also never going to equal 0. Good, so looking at our vertical asymptote, this confuses me a fair bit, but I'll do my best to explain. So our vertical asymptote is going to be the vertical line, so in this case, our y-axis. And remember that our y-axis is the line, I'm actually going to do a colon, is the line x equals 0. Because on this point, y could be any number of different things, but our x value is always going to be 0. So our vertical asymptote is the line x equals 0. Looking at our original function, we have 1 over x. Our vertical asymptote is going to be the place where our denominator equals 0. So vertical asymptote is where the denominator equals 0, because that makes our function undefined, right? Remember that a vertical line has an undefined slope, or the function would be undefined at x equals 0. Yeah, basically just remember vertical asymptote is the big one. That's where our denominator equals 0. So in this case, because it's just x in the denominator, that is when x equals 0, and that is where our function is undefined, the slope of our function is undefined. Good, so the horizontal asymptote's a little bit trickier. Here, it's going to be the line y equals 0, or the x-axis. I'm going to write that right there. X-axis, y equals 0. Once again, it could be any x value along this axis, but it's always going to be y equals 0. And how do we know that? So basically, you know how when the denominator is a 0, it's undefined? Well, I never quite understood that. I think it's because a denominator is thinking about division, right? And you can't divide, if you have 5 things, you can't divide them into 0 because they already exist. So that's why it's undefined, because it doesn't quite make sense. But it's going to be the place where if we pretend that it like could exist, like what would our output value be? So the horizontal asymptote is where the whole function equals 0, or where y equals, like, where y cancels out. I'm just going to say where the function equals 0, because I think that makes more sense. So the denominator equals 0. So here, we can never have a y value of 0. I'm going to add something over here, right? So if we're saying this is y equals 1 over x, because there's no value, like when x equals 0, it's always going to be undefined. There's no way we can make y equals 0 ever. Like, there just isn't. So how I like to kind of think about it is thinking about, like, okay, so if 1 over 0 actually equaled something like 0, what would y equal? And it would be 0, because we're kind of thinking that this would cancel, and it gives us a y value of 0. I know it's confusing, so if my like sort of convoluted explanation doesn't make sense, again, you can look back to this graph and see that y is not going to equal, like, your horizontal asymptote. We see that it never crosses our x-axis. Let me check on the table, because that's another good way. See, when we go to 0, it's undefined, right? So that's another good way to check. We see that our function is going to be undefined when x equals 0. That tells us a vertical asymptote. And we're never going to get a y value of 0. And that's just, we know that because that makes sense. And if it doesn't, this is where you could come ask a question where I can respond in real time. You can come talk to me or Miss Avra. But again, we're talking about this in class tomorrow. But just a reminder, our vertical asymptote is x equals 0. And our horizontal asymptote would be the line y equals 0. Let's move on to one that's a little bit more complicated, and I'll try to explain it better when it's not the simplest one that we have. So we have our function over here, f of x equals 2 over x minus 3 plus 1. So I'm going to put that in a nice little box. Once again, I think graphing makes the most sense. So we can pop it in our calculator. I'll do that for this one. For this next one, I'm just going to talk through it and pretend that this was in the non-graphing section. Oh, crap. I'm really bad at the calculator. I'll learn one day. Okay, good. So going back up here, I'm going to clear that out. So I'm going to type this in. So we have 2 over x minus 3 and plus 1. Hit enter. Good. So here, ooh, wow, you cannot even see my calculator. I'm very sorry. That was a waste of your time. So I will stop doing that. Here we have 2 over x minus 3 plus 1. So kind of looking and eyeballing it, we can see that this starts to dip. I'm also going to set my window to the standard. We can see that this starts to dip at around x equals 1, 2, 3. And looking here, we see that at the line y equals 1, that we also see that our line starts to flatten out. So that means to me that our vertical asymptote, I'm going to write this in the same colors. So our vertical asymptote is going to be the line x equals, because that's a vertical line, x equals 1, 2, 3. Once again, because I'm counting over 1, 2, 3, and see that that line is kind of where it makes sense. So x equals 3. The other way is when I plug in 3 for x here, my denominator equals 0, which is the definition of a vertical asymptote, right? So if I'm graphing this, which I have to do because there's a blank graph, I'm going to draw my little hatch marks, is what they're called, through the line x equals 3. Because that kind of sets up my, I like to think of it still as like the first and third quadrant of my new line with asymptotes. Okay, good. So the horizontal asymptote, again, I think is a little bit trickier. So this is where we pretend, so we have 2 over 3 minus 3. So that part's undefined. So it's undefined. We can't have any value there because it is undefined, and our denominator equals 0. So this essentially, I like to think of it as it doesn't exist, and what are we left with? 1. So once again, this kind of doesn't exist. What are we left with? 1. Another way to think about it is there is no way we can possibly make this first part, 2 over x minus 3, equal to 0. Because when we plug in a value that makes it seem like it should, it goes undefined. So never, ever will 2 over x minus 3 equal 0. So that means that we can never have a function that equals 1, because in order for that to work, it would have to be 0 plus 1, and we can't get that first part to equal 0. So my horizontal asymptote is just going to be f of x equals 1 or y equals 1. So once again with those hash marks, I'm going to draw this at the line y equals 1. Good. So now we see we kind of have a new coordinate plane. That's not quite how it works. That's how I like to think about it, where we're bound by the lines. This is y equals 1, and this is x equals 3. Once again, if I look back to my actual graph, which you guys can't see because the screen went dark, we see that it's still, we start high and go low, and then we start high and go low. So that's exactly how I'm going to draw it. Once again, I'm a terrible artist, so yikes, but I actually used to get points off on my graphs because they look too bad. But hopefully we won't be that mean to you. Can't make no promises though. So we see that. So now we're done. So we have a vertical asymptote of x equals 3, horizontal asymptote of y equals 1. We set up our new quadrant is kind of how I like to think about it. Graph up here and graph down there. Once again, any questions, you can ask me or Miss Avera. Yeah, so moving on to number 10. So we have f of x equals 4 over x plus 2. This time I'm actually just going to logic through it. Is logic a verb? I hope so. Logic through it. And then after that, we are going, I'll show you how it looks on the calculator, because I know that my handwriting is pretty terrible, so maybe we won't be able to tell. So looking at our vertical asymptote, remember that's where our denominator equals 0. So here it's just 4 over x, so when is our denominator going to equal 0? When x equals 0. So my line for my vertical asymptote is going to be x equals 0. I, for my graph, am going to draw these lines through my vertical asymptote, which is the line x equals 0. Good. Moving on to the horizontal asymptote. I'll try one more time to explain it, and I'm sorry if it is still confusing. Once again, this is where it's good to talk to an actual human being, so you can come and ask me or Miss Avera questions. So our horizontal asymptote. So here, we know that 4 over 0 is going to be undefined, so we're left with this 2. So once again, because 4 over 0 is undefined and does not equal 0, there is no humanly possible way when we do not have a variable in the numerator, here we just have a variable in the denominator, that we are ever going to make that equal 0, because the one that should make it equal 0, in my mind, 4 divided by 0, does not equal 0, it's undefined. So we have no way of making it equal 0, so therefore we will never end up with a y value of 2, because we need that to equal 0 if we're going to make that equal 2, right? And we can never have 0 plus 2 because it's undefined plus 2 instead. So I'm going to draw this vertical line through the line y equals 2 because we know it will never, ever, ever work like that, which is really sad because I really wish we could make y equal to 2. I'm sure you are as heartbroken as I am, but it just can't, you know? Such a bummer. But let's check to make sure that I did this right before we draw our lines in. Once again, it would be like a swoopy here and a swoopy there, which is a very technical term, I'm sure. So please, in your future life, never use the word swoopy to describe what I just did, but I'm through college, so I'm going to do that now. So we have 4 over x and plus 2, I think. So plus 2, hit enter. And that looks pretty good to me, right? So we see that x equals 0 looks like that line, and y equals 1, 2 looks like another line, looks pretty good to me. So let me draw in my graph part, and it would look something like this, right? So we see that it's never going to cross that y-axis or the line x equals 0, and it's never going to cross the line y equals 2, although it gets close and approaches it. Good. So once again, if you have any questions on that part, come talk to me or Miss Avera. This lesson will be really helpful going into tomorrow when we're doing another task like writing project. And it also incorporates some of that world-saving problem that we were doing. So I'm pretty psyched for tomorrow. But before this video is over, everyone's favorite part, the ACT problem. So we can see how what we're doing in class actually will help us on the ACT. So we have this problem right here. The number of students at Hamlet High School who will catch the flu through week T. I'm going to box that off right away because I already read this problem, and it says through week 4 at the end. And we know that T is in terms of weeks, so we have to do no conversions, which is super exciting. So the number of students at Hamlet High School who will catch the flu through week T of school is modeled by the function n of t equals 1,200 t. That is a squared, which I learned to be through trial and error, not because I can magically read that. So we have 1,200 t squared plus 10 over t squared plus 1. According to the model, how many students will catch the flu through week 4? So once again, I already boxed off week 4 because we know that t is in terms of weeks, which is pretty exciting. And now we have to plug and chug pretty much. So we know that t is going to equal 4. So let me set this up. We have 1,200 t squared plus 10 over t squared plus 1. T is going to equal 4, like I circled. I'll fill it in like this. You don't have to leave blanks like that. I just thought it made more sense for my color coding, but it's completely up to you. So let me type that into the calculator. I'll let you see so this video is not as boring. I'm sure all of you will fast forward through this part, but in case you're still watching, first of all, hello, and also you're welcome for showing you what I'm doing. Okay, so we have 1,200 times 4 squared. Oh, the glare is pretty bad right there. 4 squared plus 10 divided by 4 squared plus 1. Hit enter. That gives me an answer choice that is actually one of them. So that's good news. So we have 1,130. I hope you can see that. That is answer choice C. So that one wasn't too bad because it's just plugging in a value for t. Good. Moving on, we have question 20. The equation y equals x plus 3 over x squared minus 4 is graphed on the coordinate plane. No point on the graph has which of the following x coordinates. So this is a cool question because it's asking us for what? Which one deals with x coordinates? The vertical asymptote. So this is basically asking me for the vertical asymptote. So how can I figure that out? The vertical asymptote is defined as the point where the denominator, which is x squared minus 4, equals 0. So there are multiple things we could do. I think the one that makes the most sense is if you guys remember, well, actually, okay, let me collect my thoughts. Basically, you could factor it. You could use something like the quadratic equation. Don't do that. That would be way too much work. You could graph it and see where it equals 0. I think what we should do is think about these as multiple, this is a multiple choice test, right? That's a good thing about the ACT. If we plug in different values, we could find out where that equals 0. So let's try -3 first. So we have -3 squared minus 4 equals 0. -3 squared is going to be, if you're doing it in your calculator, don't forget to put your parentheses. Otherwise, it's going to say -1 times 3 squared instead of -3 squared, and those are different things. So remember that -3 squared is equal to -3 times -3, which is equal to a positive 9. So we have 9 minus 4 equals 5. And 5 is not 0, so we know it's not F. Let's try this one. We have -2 squared minus 4 equals 0. -2 squared is 4. 4 minus 4 equals 0. So we know that our answer choice is going to be G, which makes sense, I hope. So -2 squared, reminder, is -2 times -2, which is 4, minus 4 is 0. So it's going to be a -2. It also could be one other number, because we know that 2 squared is also going to equal 4, so this could actually be -2 or 2, but 2 isn't an answer choice, so it's going to be -2. Once again, any questions on this part, please ask me or Miss Avera. And otherwise, we're excited for class tomorrow where you guys are going to get to practice this skill and bring it a little bit further with some ethics. So it'll be pretty cool. See you tomorrow.